Hello, welcome to my presentation on the ramifications of experimentation into SRM in light of its impacts on existential negative state and civilization endangering risks. The acronym I use for that is Resiliencer, which is entirely non-contrived and just generally the greatest possible acronym that could have been chosen. My name is Gideon Futerman, and I've done this project with mentorship from Jesse Reynolds and Gideon, so thanks to both of them. So a quick overview of the presentation. I'm going to firstly be going through what SRM is and what that means. Then I'm going to be going through how that is relevant to global catastrophic and existential risk. Then I'm going to be going through how I approached answering this question about this. And chiefly, I went about this doing two ways. I developed a framework for what the relationship between SRM research and later actions is, and I call this the tripartite framework, and I'll go through that. I also came up with a plan for a workshop, which I'm running in Utrecht on the 12th, and finally, I might be able to have some time to go through some of the further research plans, which I have as well. So, what is SRM? So SRM, standing for solar radiation modification, sometimes also known as solar radiation management, solar geoengineering, climate engineering, or climate intervention, solar climate intervention, etc., is a way of potentially ameliorating global warming by reflecting sunlight. So basically, if you think about the way that our planet is warming, you get sunlight that sort of comes in. This gets then some of this gets reflected out, it just goes out to space. Some of this then gets absorbed by the Earth, gets re-emitted out into the atmosphere. Some of that then gets trapped in by the greenhouse gases, which is what's leading to the warming. So one way that people have proposed that we could potentially reduce some of these effects of the warming is by reducing the amount of sunlight that comes in, by basically reflecting more of that light. This doesn't reverse climate change. This induces a different type of climate change. It could reverse global warming, but it has its own problems because it doesn't address the greenhouse gases that are in the atmosphere already. It doesn't address things like ocean acidification. Also, these aerosols that you need to carry out the SRM have relatively short residence times in the atmosphere, on the order of weeks to a couple of years, as opposed to centuries to millennia, which is the residence time for greenhouse gases or for carbon dioxide. And so if you stop doing your SRM rapidly, you get really rapid warming, and that's very bad. You also potentially have risks of conflict once we can start controlling the climate. And it's very unpredictable, or somewhat unpredictable, what its impact is going to be, just because even though our climate models are pretty good, our models of aerosols and clouds and how they interact are pretty bad. And we don't really understand those very well. Yeah, one of the ways it's been proposed mainly to be used is basically to sort of artificially keep the temperature low, as in that blue diagram, whilst we reduce to zero, and then we remove CO2 from the atmosphere. There's other ways that it's been proposed to be used as well, such as just like increasing the time it takes for the climate to warm, so we have more time to adapt. Okay, why does this matter from a GCR perspective? Climate change is a potential contributor and important contributor to GCR/X risk. I'm not going to be able to go into much detail why this is the case, but there's already quite a large literature suggesting this is the case. As shown, SRM could reduce some of these associated climate risks and therefore could act as a way to ameliorate GCR. However, SRM has its own risks that contribute to global catastrophic risk as well. And the risks that it brings contribute to global catastrophic risk in a potentially different way to the sort of risks which ameliorates, meaning that actually it's rather complex to work out if we want SRM to be sort of happening or not. Both of these relate to other contributors to GCR. It's also exceptionally neglected. There's been about 3 peer-reviewed publications on SRM and global catastrophic/existential risk written, and as far as I can tell, there's only a handful, probably less than 10, possibly even less than 5 full-time people working on SRM and global catastrophic risk. There's arguably no full-time people working on it, but if you add up all the short amount of time that people are spending on this. Also, it's potentially a very important time in the SRM field to be working on this as well. SRM is potentially going to be spoken at the UN General Assembly. The US federal government is potentially doing a major research program into this. And so this is a very important time to be getting sort of considerations of global catastrophic risk and existential risk into the conversation. Okay, so my methodology of working out how SRM research relates to global catastrophic risk is basically 2 steps. how does SRM research or other upstream actions, so actions we sort of do now in the research ecosystem, how do these interact with deployment or other downstream actions which might include not carrying out like enough mitigation, let's say, or cutting the amount of mitigation, or increasing the amount of mitigation, or increasing certain governance forms, or developing certain other technologies as well. Then, how might those deployment or downstream actions affect GCR or X-risk as well? So that's sort of two-step thing. However, it's not so simple because the relations between them actually look something like this. Very complicated, very difficult to untangle, not necessarily obvious. Things that might apply in non-X-risk cases might not apply in X-risk cases, and things might apply differently depending on which scenario or world we're in. So my project is trying to untangle at least some of this mess so we can start making some degree of informed decisions about what we should do about research. So one of the ways I did this is I developed a tripartite framework defining the SRM research ecosystem. So this is focusing on this first step of the process, basically. How does research relate to deployment / downstream actions? Okay, so in fact, establish that before I then go on to establish the second part. So why is this necessary in this space? Well, there's no codified framework for what SRM is, and SRM research, sorry, not what SRM is, but what SRM research is at present, or how the SRM research system functions. The framework, the sort of quasi-accepted, but of course this is informal framework that's used, is something I like to describe as the linear framework, where you get small sort of indoor experimentation, modeling, indoor experimentation, small scale outdoor experimentation, large scale outdoor experimentation, deployment. And that's often the way that these things are viewed, that there is this linear path and the impacts and the dangers all scale with the size of the experiments. And that's the relevant factor, the sort of size or scale of the experiments in this linear pathway. This may be as useful for governance, but it doesn't actually seemingly capture the important links and the important worries in the literature around SRM research as well, or the important advantages of SRM research as well. This linear framework seems overly simplistic and not particular for trying to actually disentangle this very, very complex thing. Under the linear framework, three broad things are shown to try to be these links. One is slippery slope, this idea that you start doing one bit of research and that will lead to a slippery slope that will quasi-inevitably lead to deployment. Moral hazard, the idea that talking about SRM and upstream actions that you take now will basically stop us willingness to cut emissions and lock in a particular pathways. The problem is each of these pathways are unspecified. It doesn't capture the diverse and complex pathways that lead from research to deployment. So my framework hopefully generates scenarios with specificity and can develop, so we can go from upstream actions to work out how specifically they may lead to a variety of different downstream actions. So we can maybe work out what we should focus on, what levers we should pull to increase the probability of positive downstream actions which we want, and decrease the probability of negative downstream actions, which we want as well. It also should allow us to generate the diverse and complex pathways, which we would want to be able to see as well, to see how from any one action, a variety of different possible futures could disseminate. Finally, we also want to be able to look at what are the desired downstream actions and track back to what sort of near-term actions we should take. So I define the framework like this. I'm running a bit late on time. Oh well. So basically I split it into three. Research, the actual research itself. And this is split into knowledge research, which I define as basically the fundamental knowledge and science that is required for doing SRM, but it's not necessarily itself directly linked to SRM. So this could be fundamental knowledge of aerosol microphysics, or this could be the development of nozzles within the printing industry, which has now been used in marine cloud writing. And application research, which is how that knowledge research is linked into the context of SRM. I define both of these by their intention as well. I probably won't have time to go into a lot of detail on those, but I will quickly define the development and assessment. Development application research is research which is ostensibly about equipping decision makers with sort of the best, safest version of SRM with all the information available so that if they're in a decision where they should decide whether or not to deploy, they have the safest and sort of best option possible of SRM available. Whereas assessment research is trying to sort of assess existing proposals of how SRM research works. Then I go into the communities. Communities is drawing off the literature on epistemic communities and thought collectives. And I define these as broadly as an informal network of individuals and social spheres. Within those, you have formal communities, essentially formal institutions. For example, the Harvard Solar Engineering Program, the Center for Climate Repair, things like this. And the formal institutions typically hold physical infrastructure, but some of that stuff is also actually held in the informal communities. Finally, we have communication, which is split into explicit and implicit communication. Each of these split into neutral and messaging framings. Neutral framings are ostensibly non-normative. That's obviously not true, but they present themselves as non-normative or non-prescriptive, whereas the messaging framings tend to be more prescriptive and tend to be more explicitly normative as well. So I might end up running slightly over the presentation, but then that will just bring our first time for questions. But I want to quickly show how this framework can be used. This is to generate this concept of the moral hazard, how near-term actions could lead to us having less willingness to cut emissions in the long term via SRM. So let's say so this is an example, the formal communities have carried out assessment SRM research, and this assessment SRM research carries on within physical infrastructure, which is based within a formal community, let's say an institution like at a university. And they carried out assessment SRM research just to see if, running climate models and stuff, to see if certain SRM proposals have positive or negative effects. Then, let's say this assessment research just turned out to be broadly positive towards SRM in terms of it suggests that SRM can reduce climate impacts. Well, the assessment research itself will be doing some degree of neutral communication via the publishing in academic journals. Also, likely the formal infrastructure that carried out the assessment research will likely, via press releases and social media content and podcasts and other bits of outreach, may communicate that assessment research. And again, I'm suggesting they're explicitly communicating this in a neutral way. And you then, so saying they explicitly communicate this in a neutral way, and in fact suggest that the SRM merely, under certain circumstances, may reduce certain climate impacts. They do not call for SRM to be a replacement for mitigation. In fact, they explicitly say it shouldn't be. This may then lead to implicit messaging, prescriptive messaging communication, saying that SRM does reduce climate impacts in general, and therefore should be strongly considered. This implicit messaging communication may then lead to policymakers and people sort of in SRM research ecosystem adjacent communities, accepting that investing either political or actual financial capital in the SRM research, communication and the communities is a good idea. But they may be doing this alongside mitigation. This actually doesn't at this stage even need to come along with a reduction in mitigation desire. And they would do this. Then, to justify this expenditure, this may lead to explicit messaging communication of the positives of SRM. So this may originally occur alongside a willingness to mitigate. However, if exogenous factors come in, which reduce the desirability of mitigation, having SRM, which has already now been messaged as an insurance, as a potential sort of stopgap measure, plan B, which they've messaged, originally it was explicitly messaged as not a plan B, and now, because to justify this, it's being messaged as a plan B, which then may lead to, if there's factors that make people less willing to mitigate, policymakers and others may use this as sort of an insurance excuse to not cut emissions.
Yes.
Very quickly. Finally, I'm running a workshop in Utrecht on the 12th of September. We're getting 20 European SRM experts with diverse specialties, and this will be the first workshop on SRM and GCR. And this is one of the major things I've been doing in my project. Quickly, why is this needed? We're engaging the European SRM community in SRM GCR interactions because the SRM GCR subfield is absolutely tiny at the moment, and so we want to build this field using pre-existing experts. We're going to generate useful knowledge that would help to answer the questions that my project proposes. So we're going to have diverse input and ideas, try and develop sort of a diverse range of things, of research directions, some things which we'll be trying to be convergent, so via deliberation, some which we'll try to get divergent ideas, which is what point diversity is. We want to get expert input at an early stage and really use a workshop as a qualitative research method. Finally, we want to get a broad range of academics to provide input into this nascent research area, which is sort of uniting these two previous ones because we want to avoid locking in of a particular pathway in this field that just happens to be by the few of us that are actually working in SRM GCR, and instead, because the field's sort of pre-paradigmatic, so we potentially have this danger of doing this. And we want to generate useful next steps that we couldn't do alone. And here is the agenda for the conference up on the screen. You can read that yourself. And yeah, any questions?